In this video, we will be discussing the volume and surface area of pyramids and cones. So, a pyramid is a shape that has a rectangular base with triangular faces. All right, for the intents and purposes of this class, our bases are always going to be squares. So the volume formula for the volume of a pyramid is simply the base area times the height divided by 3. You can think of it as being 1/3 of the volume of a cube with the same edge length as the pyramid. So to do this, we know that our base is a square, so the base area is simply going to be 16 squared. And then we look at our height, and our height is the perpendicular distance from the base to the apex of the pyramid, and that's 15. So we've got 16 squared times 15 divided by 3. So 16 squared times 15 ends up being 3,840, and that's divided by 3. So we do our division by 3, and we get 1,280 inches cubed, because this is volume. So that's all we have to do to find the volume of a pyramid. Simply 1/3 of the base area times the height. Now for the surface area, our formula is L times P divided by 2 plus capital B, where L is our slant height. And the slant height is simply the height of the triangular face. Okay? The vertical or the perpendicular distance from the base edge up the face to the apex. So it is the height of our triangle. So to find the surface area, we're going to find the area of each of the triangular faces. Well, to do that, we'd simply take the slant height, which in this case is 17, times the perimeter, which is the distance around the outside of the base. Since each base edge is 16, that's 16 times 4, all divided by 2. And then we are adding to that the base area, which we know from the volume problem is 16 squared. So if we work this out, we get 17 times 64 divided by 2 plus 16 squared, which is 256. If we work this problem out, we get 1,000, maybe, we get 1,088 divided by 2 plus 256. 1,088 divided by 2, that's 544. Add our 256 in, and we get 800 inches squared, because this is an area problem. So there we go. We found the volume, and now we found the surface area of our pyramid by simply using these two formulas. So now let's take a look at cones. So similarly to how we can think of a pyramid as having the volume of 1/3 of a cube, we can think of a cone as having the volume of 1/3 of a cylinder. So our formula works out to pi r squared times the height, pi times the radius squared times the height, divided by 3 for the volume. So we look over here, our radius is 3, so this is pi times 3 squared times our height, which is 4, all divided by 3. Work this out on top. 3 squared is 9, times 4 is 36. So we get 36 pi on top of our fraction here, divided by 3. 36 divided by 3 gives us 12 pi meters cubed. All right. So this right here, 12 pi meters cubed, that is our volume in exact units. All right, we simply take pi times the radius squared times the height and divide it by 3. So similarly, our surface area is pi times the radius squared. That gives us the area of our circular base plus pi times the radius times the slant height, which will give us the area of our one lateral face that we have up here. So if we work that out, that's pi times 3 squared plus pi times 3 times 5. 3 squared is 9, so over here I get 9 pi. 3 times 5 is 15, so over here I get 15 pi. Add those together, we get 24 pi meters squared because we're talking area. That is our exact answer for surface area in exact units. So, to find the volume of a cone, we simply apply this formula. To find the surface area, we apply this formula. So now let's take a look at a practical application problem. So here we have the Great Pyramid of Giza, which has a slant height of 611 feet and a base length of 756 feet. And it was originally covered with a limestone coating around the outside. We want to find the amount of limestone that it would take to cover the entire pyramid. So to figure out this problem, we need to first figure out, are we talking surface area or volume? Well, if we look at this keyword right here, cover, that tells us we're talking about the outside of the shape, so therefore we have to be talking about the surface area. We know the surface area of a pyramid is the slant height times the perimeter divided by 2 plus the area of the base. Now if we think about this problem, the slant height times the perimeter divided by 2, that gives us the area of all 4 of the faces of the pyramid, and the base area gives us the area of the base, obviously. But when we think about this, the creators of the pyramid were not covering the base, which is in the ground, with the limestone, so we don't have to worry about that. We can in fact just say, well, this is going to be the slant height times the perimeter divided by 2 will give us our answer. So to do this, we take the slant height, 611, times our perimeter, which is 756, times 4, because the pyramid has a square base, all divided by 2. So if we do this multiplication across the top, we get 184,000. Oh, actually I'm wrong on that. 1,847,664 divided by 2. Do our division there, and we get 923,832 square feet of limestone is what would be necessary to cover the entire Great Pyramid with a limestone coating. So now we have covered finding the volume and surface area of pyramids and cones.